Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young.
Chapter 9, Geometric Constructions, Invariants. Section 84, the intersection of a given line with a given conic. Given a conic defined, let us say, by 3 points, A, B, C, and the tangents at A and B, to find the points of intersection of a given line with this conic, using non-homogeneous coordinates and choosing as x-axis one of the given tangents to the conic, as y-axis the line joining the points A and B, and as the point 1, 1, the point C. The equation of the conic may be assumed to be of the form x squared minus y equals 0. The equation of the given line may then be assumed to be of the form y equals px plus q. Footnote: there is no loss of generality in assuming this form, for if in the choice of coordinates the equation of the given line were of the form x equals c, we should merely have to choose the other tangent as x-axis to bring the problem into the form here assumed. The domain of rationality defined by the data is, in this case, k equal 1pq. The elimination of y between the two equations above then leads to the equation 1 x squared minus px minus q equals 0. This equation is not, in general, reducible in the domain K. The problem of determining the points of intersection of an arbitrary line in the plane with a given conic in this plane is then a problem of the second degree. If equation 1 has a root in the field of the geometry, it is clear that this root gives rise to a solution of the problem proposed. If this equation has no root in the field, the problem has no solution. If, on the other hand, one point of intersection of the line with the conic is given, so that one root of the equation 1, say x equals r, is known, the domain given by the data is k prime equal 1pqr. And in this domain, 1 is reducible. In fact, it is equivalent to the equation, the quantity x plus r minus p times the quantity x minus r is equal to 0. The problem of finding the remaining point of intersection then depends merely on the solution of the linear equation x plus r minus p equals 0. That is, the problem is of the first degree, as already noted among the examples of linear problems. It is important to note that equation 1 is the most general form of equation of the second degree. It follows that every problem of the second degree in a plane can be reduced to the construction of the points of intersection of an arbitrary line with a particular conic. We shall return to this later, section 86.
Projective Geometry, Volume 1. This book was written by Oswald, Veblen, and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.